Hi, today we'll discuss one problem. A 50 ml solution of 0.200 molar HCl is mixed with 0.30 ml of 0.150 molar NaOH. Calculate the pH of the resulting solutions. So what we'll do is that first we'll see what are the information is given here, right? So first is the volume of HCl, which is 50 ml. We'll convert this one to liter. Why we are converting this to liter? Because we know that from the definition of molarity, the number of moles present per liter, right? So we need to convert this ml to liter. So 50 ml, which is equivalent to 0.05 liter. Now the concentration of HCl is 0.200 molar. Okay. Then the volume of sodium hydroxide, which is given 30 ml, again we will convert this one to liter, which is 0.03 liter. Now the concentration of sodium hydroxide, it's given 0.150 molar. Now we'll solve this problem step by step. First step is that we need to calculate the number of moles of HCl. How we'll calculate? This is basically we have to multiply the molarity with the volume. Okay, the molarity given is 0.200. We need to multiply with the volume. The volume should be in liter, which is 0.05 liter. We'll get 0.010 mole. Now, similarly, we'll calculate the number of moles of sodium hydroxide also. So here also we need to do m into v. M is already given and v we have converted to liter. So we'll get it 0.0045 mole. Now is the vital step. Here we need to see what kind of reaction it is happening, right? So here we need to see the reaction scheme. The scheme is that HCl plus NaOH is giving NaCl plus H2O. This is very famous acid-base reaction where acid reacts with base to give salt and water. But here interestingly what happening is that one equivalent of HCl reacting with one equivalent of sodium hydroxide to give one equivalent of sodium chloride along with one equivalent of water. Okay, that means if we have 0.0045 moles of sodium hydroxide, that will neutralize 0.0045 moles of HCl. Why we are considering sodium hydroxide? Because sodium hydroxide present here less, right? And the HCl is more. Now, so what will happen? The remaining HCl will be extra only. Now we need to calculate the how much mole of HCl is extra. For doing so, we need to subtract the total HCl volume, okay, which is total HCl mole, number of moles of total HCl, which is 0.01. We need to subtract 0.0045 moles, right? What we will get is that 0.0055 mole. So this much mole is extra. Extra what? Extra HCl, right? And now we got that how much extra moles of HCl is there. Now we need to get how much is the total volume, right? We added 50 ml with 30 ml. Total volume was 80 ml. If you convert this one again to liter, it will be 0.08 liter. Now we can calculate the molarity of HCl, because for calculating the molarity of HCl, what we need is that number of moles and also the total volume. Total volume should be in liter, right? We have the number of moles is 0.0055 and the total volume is 0.08. Okay, so if we divide these two, we'll get is that 0.06875 molar. This is the molarity of H plus. Okay. Now in the final step, which is step 6, we will calculate the pH. pH, what is pH? pH is the potential of hydrogen. How we calculate this one? We calculate pH equal to minus log 10 of H plus. This is the molarity. Okay. So now minus log of H plus, that molarity we have to put it here. So 0.06875, it is going to give you 1.16. So the pH is around 1.16. So this will be the answer. So here what are the things we need to remember or we need to point out? That pH is the potential of hydrogen, which is expressed at minus log 10 H plus, and also molarity is that number of moles has to be done in per liter. Okay, thank you, hope you have understand. Yes.